The last main method we're going to learn for integration in Calculus BC is integrating using partial fractions. And again, this allows us to solve some integrals that we could not previously using the rules we've learned this far. So I'm just going to dive in with an example so we can just see how it works. And we're going to start with the integral of 1 over x squared minus 5x plus 6. Okay, if you look at that, u substitution would certainly not work. Your u would be the bottom, du would be 2x minus 5, and that looks nothing like the top. It's not a... it looks a little bit like an inverse trig problem since the power on the bottom is bigger than the one on, a lot bigger than the one on top, but it won't work there either because of that x term. So that only leaves us with the option of separating this and splitting it into partial fractions. Now here's what that means. We're going to ignore the integral for a second and just work with the fraction, and we're just going to try to rewrite it. Now if you notice, we can factor the bottom. Now that's key here, being able to factor the bottom. That factors would be x minus 2 and x minus 3. So we're kind of doing the reverse of what you probably are normally used to. You're used to finding a common denominator and then combining two fractions into one. We're doing the opposite. We're taking a fraction and splitting it up into two. And we're doing 2 in this case because there are two terms on the bottom. So we would have a over x minus 2 plus b over x minus 3. And we put the a and the b there because we really don't know what's supposed to go on top yet, so we need to figure that out, and we'll just put a and b there to help us do that. Okay, we need to solve for a and b, and it's not really easy to do when we have all these denominators, so let's get rid of those. The way we do that is we multiply everything by the common denominator, which if you notice, it's just going to be identical to whatever's over here. So on this side, it cancels out completely, and all we'll be left with is 1 equals. On this side, we have x minus 2 canceling out, so that just leaves a times x minus 3. We have x minus 3 canceling out, so then we have b times x minus 2. Okay, so we need to solve for a and b. Now remember, x is a variable. That means we can plug into it anything we want to. A and b, on the other hand, are unknown constants. In other words, they have a specific value, we just don't know what they are. So what we do is we choose what are called convenient values of x. Sorry if I just repeated myself, I got interrupted for a second. We need to pick a value of x that'll make it easy to solve for either a or b. And if you look, the convenient value is going to be something that makes the term 0. So here's what I mean. Let's just look at this first term, a times x minus 3. If I choose x equals 3 and then plug that in for x, I'll get a times 3 minus 3 plus b times 3 minus 2. Well, 3 minus 3 is just 0, so that term just cancels out, and I get 1 equals b times 1, so b is just equal to 1. That's simple. Now we just need to figure out the other convenient value of x in order to solve for a. Well, that's going to knock out b, so we would choose x equals 2 to make that x minus 2 term become 0. Okay, so 2 minus 2 is 0, that just cancels that out, so we end up with 1 equals a times negative 1, so a is equal to negative 1. So now we can go back up top. Well, we'll just rewrite it. Now we can rewrite the integral as negative 1 over x minus 2 plus 1 over x minus 3. Because that is equivalent to that original fraction we had of 1 over x squared minus 5x plus 6. And now it's a very simple integral, and it's almost always going to end up being the natural log, just so you know. This first one is negative natural log of x minus 2. You can use u sub individually here if you want. You can use u sub for this piece and then use u sub for this piece, but this is the result you'll get. Plus natural log of x minus 3. And then, of course, plus c. Now, I am completely fine with leaving the answer that way, but they will often combine these, because if you remember the properties of logs, you're allowed to combine adding or subtracting into one log. So it's simpler here really to reverse the order of this and do natural log of x minus 3 minus natural log of x minus 2, because when you subtract, you're allowed to combine them by dividing. So that would be the most simplified version, but I'm also very okay with this. This answer is correct. Just be aware the back of the book or multiple choice question may rewrite it in the way I have down there at the very bottom. Okay, let's do another example. Let's try the integral of x minus 28 over x squared minus x plus 6. And we choose u equals x squared minus x plus 6, and then du would be equal to 2x. Oh, wait a minute. It's clearly not going to work to do u substitution. So I would suggest try u substitution, because there's still going to be some they throw in, they're going to be u substitution. But if u substitution fails and it doesn't look like it's something else we've learned, inverse trig or dividing out or long division, then this is probably what you need to work with. So it is going to be a problem where we use partial fractions. This is also called partial fraction decomposition. So the first step we need to do is factor the bottom. Let's see, it'll be x minus 3, x plus 2. Okay, I believe that's correct. Yes. So now I'm just going to ignore the integral for a second and just try to decompose this fraction. We'll put the integral back on in a minute. And that's going to be equal to a over x minus 3 plus b over x plus 2. And again, we want to multiply everything by the common denominator, which is which is just this denominator over here. Okay, and you're probably noticing some patterns here and some ways you might be able to shorten this process. That's great if you can. I just want to make sure I do it as clearly as possible. So here they all cancel out, and notice you have something on the left side. You have x minus 28. It's not just a number this time, like it was in the first example. Here the x minus 3's cancel, and I have a times x plus 2. And I cross out the x plus 2's here and get b times x minus 3. Just so you know, it doesn't matter where you put a and b. You can get the correct answer by putting a over x plus 2 and b over x minus 3. The key is just if you put a on top of x minus 3, when you solve for a, you better put it on top of x minus 3. So just make sure you're consistent throughout your problem. Okay, once again, we get to this point, we're trying to find convenient values of x. So in this case, I'm going to use negative 2 first. Notice I need to plug it in on both sides. So I plug it in here, and I get negative 2 minus 28, which is negative 30, equals a times 0, negative 2 plus 2, plus b times negative 5. Negative 2 minus 3 is how I got that. So this clearly just cancels out. And if I divide both sides by negative 5, I get b equals 6. Okay, the other convenient value of x would be 3. So 3 minus 28 is negative 25. And I get a times 5 plus b times 0. Again, I'm plugging in 3 for x. And the 0 just cancels out the b. If I divide both sides by 5, I get a equals negative 5. So now I can do the integral as negative 5 over x minus 3 plus 6 over x plus 2. I do the natural log. I get negative 5. Just pull that constant on top out front. X minus 3 plus 6 natural log of x plus 2. Okay, now remember you can move. I'm going to switch the order here, and I'm also going to move those coefficients up as exponents. Try this again. Sorry, x plus 2 to the 6th minus natural log of x minus 3 to the 5th. And when we subtract, that would be dividing, so I would get natural log of x plus 2 to the 6th over x minus 3 to the 5th. Alright, the last example is going to be the toughest. In fact, it's probably a little tougher than most of the ones you will see, but I just want to make sure you know all the possibilities that you could run into. Let's see, 2x cubed plus 5x squared plus 2x. Alright, so first thing that makes this one a little different is we're going to have to factor into three pieces. If you notice, there's an x in common with every piece on the bottom, so part of that's just going to be x when I factor it. And then I've got to factor this with a 2 as well. So let's see. I believe that's going to factor out to be 2x plus 1 and x plus 2. Let me double check. 2x squared plus 4x. Yep, that'll do it. Alright, so I've got three pieces this time. So I'm going to have an a, a b, and a c. So 3 over x times 2x plus 1 times x plus 2 equals a over x plus b over 2x plus 1 plus c over x plus 2. Now the worst case scenario here is just that you're going to have to do a convenient value 3 times instead of twice. It's a little longer, it's not really any harder than when it has three pieces. But we do need to multiply everything by the common denominator. Whew, alright, lots of this. And x, 2x plus 1, x plus 2. Okay, so start canceling out. It cancels out completely over here, leaving us with just 3. Here it cancels out an x. So a is going to be multiplied by 2 of the pieces, 2x plus 1 and x plus 2. Okay, and b, the 2x plus 1 cancel, so I'm left with bx times x plus 2. And here on c, x plus 2 cancels, so I get cx times 2x plus 1. So like I said, you're going to have to do 3 convenient values of x, because there are 3 pieces. So the first one I'm going to use is negative 1/2. Okay, so I get 3 equals, and if you notice, that will cancel out this piece and this piece, so I'm not even going to bother with those two, because they're just going to become 0. And I'll get b times negative 1/2 times 3/2. Okay, so I get 3 equals b times negative 3/4. And if I divide both sides by negative 3/4, I should get b equals negative 4. Alright, next I'll choose the negative 2. And the order you do these convenient values in doesn't matter. If I do negative 2, it cancels out this piece and this piece, so all I'm left with is the c. So I'll get 3 equals c times negative 2 times negative 3. So that gives me 3 equals 6 times c. So c equals 1/2. And then finally x equals 0 will be my last one. We use red to underline these. That'll cancel out this and this, turn those whole pieces to 0, so it just leaves me with the a side. So I get 3 equals a times 1 times 2. So that gives me a equals 3/2. Just divide both sides by 2. Alright, so I had a little trouble seeing here. Bear with me. We're going to have 3/2 over x. Negative 4 over 2x plus 1. And finally, we will have 1/2 over x plus 2. So we just do the natural log, and the only other warning you need here is that since there's this 2x plus 1, you actually need to divide by 2, because if your u equals 2x plus 1, your du is going to have to be cut in half, and you have to u. So actually have a 2 natural log of 2x plus 1. And then a 1/2 natural log of x plus 2. So watch out for those coefficients. If you have a piece like this, it may be a good idea to go ahead and use u substitution.